Welcome back to Stationeers. And before we get into today's episode about harvesting heat automatically from the atmosphere, I thought we'd just review a few of the patch notes on the beta branch because there's been quite a few of them, bit of a flurry. While I'm not going to be covering them all in episodes, I thought I'd mention them. First of all, Station PD, we'll take a look at that when we're actually in game, but basically we press F1 and there's some information on there. Be interesting to see if that's going to take over from the unofficial wiki. But let's continue on. So a few bits and pieces, no real problems there. It just looks like some improvements to chunking pool management. So basically that should improve performance a little bit. We'll see how well that works soon enough. Some help stuff, some tutorial stuff. That's not a problem. We don't need to worry about all of those things. New reagent, gas, and much more information to Stationpedia, fair enough. New gas, nitrous oxide, and it comes out of silver and lead ore output. So presumably when we smelt those in the arc furnaces, we can pull silver and lead out, or indeed the regular furnaces. But yeah, I don't have anything to filter nitrous oxide at the moment, which means it'll probably end up in my pollutant tank or something, because that's the end of the chain. Okay, so little bits and pieces, nothing there. Max quantity is a logic slot type, so we can create the quantity and max quantity of a slot for easy diode displays. Don't touch diode displays yet, but I'm sure we'll get to them. A really nice improvement here to essentially the automated hydroponics, so you can tell whether the plant is mature or not. Remember, we were using stage 4 as the trigger. Now you can just say, hey, is it mature? Makes it much easier. Okay, fixing some other operations, we don't need to worry about that. Setting value on circuit housing not persisting through save and load. I was noticing some weird things like it changing the program that was loaded on save and load. I'm not sure if that's the same thing. I kept my iron system to the ingot system to pull ingots out of our manufacturing system. That was resetting to hydroponics every time I'd load the game. Really quite annoying. Got some changes to the doors. So there's a logic mode for the doors, so we can change operate mode to 1 and use buttons to control the doors. Interesting. And that's pretty much it. So let's get into the game and let's take a look at that Stationpedia quickly. And we're in game, so let's see if that actually works. Stationpedia, okay, it's sort of a little bit too transparent, I think. To enable the mouse cursor while playing, yeah, we sort of have to look at a dark surface to help this, but I've got a light on my back, so yeah, great. So we can scroll through and look at various different bits. So why don't we look at, what do we normally need? Maybe let's go look at smelting. Okay, produce gases. List of gases. Okay, it's quite basic at the moment, but let's hope that that changes over time and we get something a little bit as good as the out-of-game unofficial wiki. So let me just sort this out before we get any further, just to make sure that doesn't go out on me while I'm doing stuff. I've got a pipe analyzer. You'll see why in a minute. And we're also going to want some more of the heavy cable coil, I think. How much have I got? Anything? Probably not, so let's just go and stand here, and I'm just going to make sure I select the heavy cable coil, and we'll just convert the rest of our gold into it once it finishes cycling. It's coming in now. You need the copper and the gold. That's not much. It's probably going to be about 6 sections. I need to get more gold. There's some over there. In fact, there wasn't some over there. I think I've already used it. Okay, on with the episode. So if you remember last episode of Stationeers, we were over here and we were making this system to harvest heat from the atmosphere. We're going to pull in some heat during the day. And by the way, I got some feedback saying it's not really day and night. Yeah, I know. When I'm saying day and night, what I'm really meaning is when the atmosphere is as hot as it can be and night being when it's as cold as it can be. So during the day, i.e. when it's like now, like that 19 degrees C, we want to be pulling atmosphere into our chamber. And at some point, or we can just run the coolers when that's happening, and we'll continually try to cool that gas and harvest the heat from it. And then maybe when the temperature drops below 0 or below -20, there's only one piece, then we can harvest it all again. Sorry, not harvest, reverse these vents. and we can push all the cold gas back out again, or cold-ish, and then start it all over again when it comes daytime again. So why have I got a pipe analyzer? Well, we're going to need some extra information to be able to make decisions on this front, and one of those things is that we need get on top. I'd kind of prefer, yeah, I think I'm going to put it like that. And we should have enough. I'm going to need a few pieces of the heavy coil, and we're also going to need more heavy coil to connect to all of these. But the principle is sound. I don't need to actually wire them all up until I'm happy. We're also going to need another gas sensor, and we're going to need one out here with everything else. So easiest, ooh, I'm running out. Well, I'm not running out of places because we don't really need the switches, but I'll put it over here anyway, just so I can keep the switches while we're actually sorting that out. So a gas sensor, and let's drop that off, and let's rejig this. So change U to a junction, and all we're going to do is just rename that over to be the outside gas sensor, something like that. Outside gas sensor. Okay, we've got one in there already, of course, so I don't need to do anything with that. And then this is going to give us our, not our furnace, but our sort of hot tank analyzer. And we'll be able to get the pressure and the temperature from that as well. So that's pretty much all the information I think we need. I'm just going to go and make more cable now, and of course you don't need to see that. So once I've finished, I'll come back and we'll put the computer down out here and then start looking at the electronics side of things. Or rather, I'm going to talk about electronics a little bit before I get to the actual coding, just so you get an idea of what we're going to need to do. Okay, got lots more cable coil, or at least enough to connect up 3 active vents instead of just 1. Mainly because I want to see the same amount of active vents active on the outside as we have passive vents on the inside. Remember, with hydroponics, we tried to balance those a little bit and see how well that does. So we've got 3 hooked up, and of course we've got the rest of the tower. If we're able to put more passive vents on the inside, probably on the inside of this block space here, sorry, on this space that's hidden behind this block. And, you know, we have room to add 4, 8, 9, 10, yeah, exactly. We can get quite a lot in there. So that's fine. I'm going to need to turn on all of this electronics, of course. So why don't I do that? And it's going to be right there. And everything should turn on. I'm going to turn on the pipe analyzer. There we go. And should all be active up here. You are. Good. Let's turn the computer on. And let me just import. Yep, that is the previous code we did for the encoding. So let me just clear that out and export it back out. So there's nothing in the code right now. And there's still a bug. If you turn away and press space, it will cause the circuit editor to pop up. So here is the housing. And we've got to decide what we want to hook up to this thing and what we're going to output to. So we're going to need 2 pins with that encoding. I don't think we're going to need enough inputs and outputs to worry about encoding. We're going to need 2 outputs for the batch writers. Because they're going to be controlling the, let's have a look, the wall coolers, yeah, the active vents. I think we're actually going to need a 3rd batch writer as well, but that's fine. What are we reading on this one? The internal gas sensor. Well, we're going to be able to read that directly with code, so we'll be able to, should be able to replace this with a batch writer once we get to that point. Okay, now, what are we doing to the batch writing? So we need to turn these on and off. And we need to change mode. And I think mode is, well, let's check. So let's take a look at this. Mode is currently 1, and that's with it set to inward at the moment. So pulling into the pipes, I believe. So if you want to basically fill the system, we set mode to 1, and otherwise we set mode to 0. And then of course we have on and off, etc. to do that kind of thing. All right, so we're going to want to then, well, we need some kind of output for the batch writers to pull from. And we can't connect them directly this way. And we can only expose one value by the setting on the base device. So we probably want to just use memory units. And because I need 3 batch writers, I'm probably going to need to just print off a little bit more cable. And we'll connect up a few memory units. The memory units can be written to easily enough with our program, and then the batch writers can grab the values just fine. So I'll print a few more, and then we'll get writing with the code. And apologies, by the way, if you hear me pausing occasionally, that's my body basically telling me to cough. And I'm suffering a little bit at the moment. Not so much a cold, just a cough. But yeah, sorry for the pauses if you do actually hear them. So we've just got some of the logic memory units down here and connected up to everything else. So we're going to want to say something like active vents on. And that will do fine. And active vents mode, maybe. Vents mode. And what's the other thing we're going to need to control? The active vents, the wall coolers. And that's also going to be a batch writer. Wall coolers on. Okay, and I think that's pretty much everything, isn't it? I think so. Okay, so I'm going to need to replace you with a batch writer, the same as all of these, and then that will be good. And we'll get started with a bit of programming. Okay, I really hope aliases are fixed. If they're not, I'll have to put comments in front of all these lines, but let's hope they are anyway. The next thing I'm going to do after setting these up, so we've got the wall coolers on off, active vents on off, active vent mode, the tank analyzer, if you like, the outside sensor and the inside sensor. After that, I'm just going to set some values, and I'm just going to use, is it move? I think it will be move, won't it? So let's take a look. I'm making sure I show you this rather than just getting it on screen, just so you get the idea. So we're going to move into, let's say R10. Let's just create a value, and let's just say 273. That's in Kelvin. Well, that's going to be Kelvin, so 273 just basically means freezing, as in water freezing, for all the people who work in Fahrenheit. I'm sorry. So move R11, and let's say, I don't know, what do we want to say? Maybe 223? Let's say that as a lower limit. So you want to cool down to at least that level. And maybe I'm just misremembering, but I'm almost sure there should have been an A less than B instruction, but I can't see it in the list. It's either been removed or I am really misremembering. If anyone remembers it, please put it in the comments below. But it's really all relative to 0 for this greater than or less than. So we should be able to do that. So if the temperature is 273, sorry, if it's 274 outside, it's 1 degree above 0. All we have to do is take it away from, take 273 away from it. So that's fine. We can, for example, then subtract store in R0 minus R10. So that line is basically correct. Well, not correct. Prepare temperature. Yep. And then we're just going to have almost remembered to actually do this correct way around now. So yeah, we're just going to branch to line B, or maybe is there a BRGE0? BRGE0. Yes, there is. BRGEZ even. BRGEZ. So branch line B if A is greater than or equal to 0. So R0. Ooh, actually, I want it less than, don't I? Yes, I want it less than, so BRLEZ. And the reason why will become clear in a second, but we're going to test this, and if this is below this value, it's going to jump. Otherwise, it's going to continue execution. So we're going to do that. We're going to say, this is relative, of course, so we're going to skip 3 lines, I would have thought, or jump 3 lines. And if A is, oh, it needs to be A first, doesn't it? Yep, so A is going to be R0 and then 3. Yep. So then, if that isn't the case, i.e. if we're too warm, we're going to want to then, first of all, make sure the vents are on and make sure the vents are set to the right mode. And it's mode 1, isn't it? So we're going to be able to just store onto active vents. Let's just make sure I've got the S command set correctly. There we go, S. So that's a D, so in this case, active vents. Okay, and then we want to store the on state 1. Yep, on state 1. And store active mode. In fact, that can... Oh, no, these are two different values, aren't they? Because they're two different memory units. So it's not on. That's going to be dealt with by the logic writers, batch writers. This is just setting. Because all we're doing is storing a value, which makes it much easier to remember. And the next thing, of course, is going to be the next line. So this is going to jump 3 lines. So 1, 2, and then 3. I can never remember if that's inclusive or exclusive, that 3 lines, but debugging normally solves the problem. But then we're going to jump. So we know at this point it's too cold for that. So we're also going to then jump, I think, to... Let's see. Do we need to jump? We've just assessed whether it's warm enough. We've turned everything on. The next thing it's going to test is, again, the temperature, maybe? Or are we just going to do otherwise? Interesting. Yeah, we should probably test whether it's too cold. Okay, I've added a little bit more code, and let's see if this actually works. So we've got... It's daytime right now, so it's wall coolers are on. And active vents are mode 1, so feeding in, and active vents are on entirely. However, external is 0 kPa because I'm not there. There we go, 9 Celsius. So yeah, what should happen is when we hit 0, if our program is working correctly, it should, I think, just... in fact, these may well stay on until it actually... Yeah, I think I've actually programmed a Schmidt trigger. Whoops. So, well, we'll see shortly if that's the case. Let me show you what the code is, and then you can diagnose while I look through this. So here we are, 2 sets of code. One's basically doing this first section, which we just wrote, saying now we're going to skip over 4 lines, or skip 4 lines. Basically, if it's warm, we're going to turn on the vents, change the mode to 1, and turn on the coolers. If it's too cold, remember this is now greater than equal to 0, so it's flipping it the other way around, i.e. we're going to skip over if it's too warm still, instead of too cold still up here. That's all that these 2 lines do. And I've changed this subtract line so that we don't modify the value of R0. We're just storing in separate R3s and R4s because we're manipulating that R0 twice here. Again, preparing by the cold temperature instead of the hot temperature. So here we're also preparing the temperature just to compare to 0. Yep. And then in this case, when it's too cold, what we're going to do is set the vents still on. So the vents are always on, do one thing or another. And that's one thing we may want to change with pressure. This shouldn't blow out behind me because they've got steel blocks all the way around. But, you know, if that's something we need to take care of, we need to take care of it. The active mode is then set to 0, i.e. exhaust, and the wall coolers are then shut down. Okay, so let's just take a look. It is nighttime now. Has that changed? Wall coolers are still on, active vents mode 1. Nope, that's still working. So something's going wrong. That's not unsurprising. What's probably happening is, excuse me, it is probably not jumping to that second part of code. 1 second while I debug. And that's working now, it seems. Once it gets cold enough, that is, it starts working. It's just really to do with this value. So it's not going to go when it hits 0 because I set the value too low. And that's no problem. I just moved the start up here as well, just so that we can make sure we're continually gathering the outside temperature. And so one of those two actually changed it, so everything's working. So we're sitting at minus 75 here now. And what I think I will do is just also output the... I think we're just going to make sure I constantly go to output the... Is it going to be the tank temperature? Store onto the base setting and then an R number. So in this case, the tank. Okay. Or just R2 actually. Yeah, R2. Save that. And then we can have a look just here. We can see just what the temperature's like. We could put a display here as well. Now that's dropping at the moment because there's no heat to harvest. And remember, we've just evacuated all this stuff from inside. The coolers are off. Everything is basically working as I expect. It's basically set to exhaust everything. Yep, set to exhaust everything. And that will cool down overnight. Not very much though. So it's 749. Now, I think that's gained 50 degrees. I think before I started this, I tracked it at around about 700. So the other thing I'm going to want to do is just bypass all of this when it hits a certain temperature. And that's going to be another value. So let's just add into here, move value of R12, and this is going to be our set temperature. So let's say 1200 degrees, okay? And then if it's 1200 degrees, I'm going to need to jump to another value. So what I'm going to do is we need to assess that first, I think. So I'm going to go to a specific line number here. I think I'm not going to... yeah, how are we going to do this? So let's just create some lines. So we're going to subtract and store in R5. Okay, R5. R0, which is that's the outside sensor. I actually want R2, the tank temperature. And again, we're going to take away this value. So as soon as it passes 1200, in fact, let's just submit that 1250. And this is in Kelvin, of course. So as soon as it does that, basically, we want to jump somewhere else. So BRLEZ, Z, depending where you're from, R5. And then, in fact, I don't want relative. I actually want absolute here. So BLEZ, R5, and then a value. So if I scroll all the way down here for a second, and I'm going to need another thing here. So, in fact, not here. Whoops, my mistake. I'm going to need another marker coming back up here, if that's the case, I think. So we'll put another marker. Let's just call it return for now. No, I shouldn't call it return. Wrong word in programming. Well, let's say not hot. Okay, and let's jump down to a line below our main loop. Let's say 33. So if it's less than 0, so if the temperature is 1251, let's say, we've subtracted, that means it's above 0. So if it's less than 0, we want to jump to 33. Otherwise, continue, which is fine. And in 33, I'm just going to basically shut everything down. So store active events, setting 0, store active mode, setting 0, and store wall coolers, setting 0. And then we're just going to jump back to not hot. Or was that what I called it? Yeah, not hot. Okay, so all that's going to happen is it's going to assess whether we're over our set value, which is this. This is here. So let's just put a comment in saying, I don't know, tank will be kept to this temp. And then let's put a comment in after this. So start the fans, please. Some of you may get that reference. Some of you may not. And then purge temp. Okay, so that's how everything's going to be set up, and hopefully that will work. So I'll export that, and of course I can't really test it until it gets to that temperature. However, now, hopefully, everything should be start drawing in. It is. So the wall coolers are on, the active vents are on, and the mode is set to inward, and now this is gathering temperature again. So 751, 752, 753. So that's actually a little bit faster than I was doing before with heaters, quite a bit faster in fact. And we can just see it outside here as well. And we've pretty much got everything done. So nice little episode. I will put the comments in a paste, put the program in a paste bin so you can try it for yourself. And I'll monitor how much power we're using by doing it. Remember, wall coolers still do take power, but we can see how much power they're using our network analyzer, I think. So let's just quickly take a look at that before I finish. Remember the wall heaters sort of spike up to 1,000 watts each, and we had 4 of them. Not sure how well the wall coolers are going to do, but this should let us scale quite well, hopefully quite easily. We'll see. Let's scroll there. So the wall heaters are all off. And we're going to scroll down to the wall coolers, which should actually be on. And are they not on this network? Wall coolers. Are they just called tank? I don't think so. Oh, there they are. 100 watts each. Okay, so not jumping to 1,000 watts. And we've got 6 of them. So when in operation, this uses 600 watts and pretty much heats our heater up. So if you like the episode, feel free to thumbs up, comment, like, subscribe, as you normally would. And we'll see you next episode for more Stationeers. As always, guys, thanks for watching.